Hello, my name is Terry Lane. I have developed a product called C-Vue. It's a low-cost, portable liquid chromatograph. We originally developed this product to provide kids in high school in the STEM programs to use for teaching them the fundamentals of chromatography. After working with it for a while, we found if we used high-performance columns, we could get similar performance to what one would get with a much more expensive instrument. So let me begin by introducing you to the instrument. All HPLCs consist of a pump, an injector, a column, and a detector. In our case, the pump consists of this part here, which is a bolt driving a spring, which is held inside of a piece of pipe. We compress the spring to, in this case, 50 millimeters of compression. That gives us constant pressure on the back of the syringe, therefore constant flow through a filter, through the injector valve, through the column, through the detector, and then out to waste. Or may not be waste. You may want to capture this, but we'll discuss that later. So what I'm going to do today is to show you how to do an injection of a fentanyl sample. We use a little inexpensive syringe, which is about 20 cents from the drugstore. We'll pull up about 40 cc's. I'm working with fentanyl, so I'm going to do what I suggest you do. I wear gloves and a mask. I don't know if you have been exposed to fentanyl or trained about how to work with it, but it is extremely dangerous. Capturing the bubble at the top, I want to push it out. I keep this here in case there's any spills. I can swab them up immediately, and I'm going to dispose of it by putting it into a solution of bleach. I'm pushing this in here. This is back in the inject position, rotated toward me. So I'm going to take the lid back off so we don't want any spills. I'm going to capture all that comes out of the loop. I'm pushing this through up to about 0.1 milliliters. I'm going to stop right there. I'm going to come over to here, and in one motion I'm going to inject this way and start the data system running. I'm going to put this back on here and close it up. In case there's any spill, we want to capture that. Okay, this is running. While that's going on, I want to keep this at 50 millimeters of compression. Still there. Now we have flow going through the column. The sample is being swept out of this loop, in through the column, across the column where it's separated, then into the detector and out to waste. We will go ahead and waste this one. If you come over to the data system, you can watch the chromatogram come out. In about a minute, we will have what's called the void volume, or the V0, which is the little phenomena that occurs when a component that is not retained goes straight through the column. The fentanyl will be retained, so it will come out later. The system comes, as you see here, with the data system. You need to provide your own laptop, but we can provide that also, but we divide them the same as you do. We do load the software and test it if you decide you want to get it all as a system from us. So now that the sample is inside the column, I'm going to take this mask off so I can not look quite so much like Dr. Frankenstein. This is the void volume now. This is the solvent. It's a little refractive index phenomenon where the solvent goes through the detector, and it does a few dipsy doodles, and it'll come back down and settle in. We're still at 50 millimeters compression, so we should have constant flow, which should give us reproducible retention times of the fentanyl. All of this stuff that occurs at the very beginning is meaningless. You can't really say or do much with anything there because it's not retained long enough to be able to depend on it being separated from other components. what we should see coming out in about another minute or two is a Gaussian shaped peak that should be symmetrical, we hope, and that would indicate that it is a pure component. Since the standard contains nothing but eluent and fentanyl, there should be a symmetrical peak. And we take this information, the time that it comes out of the column from 0 out to the time of the peak, the top of the peak, is called its retention time, and that provides us qualitative information. That is, it tells us that that peak is fentanyl because it comes out at exactly the same place as a fentanyl standard. The area under the curve will tell us how much is there when we compare it to a calibration which was done previously. So we should be seeing a peak shortly. I know that those of you who are doing this analysis are dealing with a very high stress situation, so waiting this period of time may seem like an eternity, but in fact we have to have the column, it has to be in the column for some finite period of time. Typically, the peak you want to analyze should be retained at least twice as long as the void volume, so you can count on it being separated from other components. I believe that's our fentanyl peak just starting to come out. Now it's drawing a peak because fentanyl absorbs light at 214 nanometers, which is the wavelength given off by a zinc lamp. So what you're seeing is the shadow of the fentanyl, all the fentanyl molecules as they go in front of the detector, and the path between the lamp and the detector. They're absorbing the light, so you're seeing it go upscale, which is indicative of a reduction in the amount of light that gets to the detector. Now we want to turn around and go back south and rejoin the baseline, and we will have seen the population of fentanyl molecules as they go by the detector. If you were doing this in a case of involving someone's life or forensic reasons where you may want to prosecute someone for possession of fentanyl, instead of the effluent from the detector going out to waste, you would capture it in another vial and store that peak. You would start capturing when the peak starts coming up, and you would stop capturing just about now. You would label it and store it, and that could go to another laboratory, and you could analyze it by GCMS or whatever tool that you choose to use for confirmation. Okay, we're just about through with that peak, so I'm going to come up here and stop. It's going to give me the opportunity to store that. I'll just do it today's date. This is January the 13th of 2017. We're going to store it under Documents and C-Vue, and we're going to put it down here underneath Fentanyl. Okay, so now we're going to come over to the next step. We've stored that data. We're going to go to Analyze. We're going to come up here and open it. Raw data. We're going to go back to Fentanyl. We're going to open this. There's the chromatogram. So I'm going to come here and manually draw this peak off. I'm just going to select, this is a beginning point, and this is the ending point. That draws it off. We come down here, we're going to name it. We'll call it Fentanyl. Then we'll just put whatever you want to put in there for how you would define it. We're going to come down here, and then we're going to load the fentanyl calibration, which was done previously. And we'll say done. We come down to Analyze, We didn't do any dilution, so we'll say, oh, this is correct. If you had diluted the sample, you could make the correction for it there. So we say analyze, and it tells us our standard is about 50 ppm, and we found 50.18. So that's pretty close. I hope you're doing well, and I hope this was informative. If you want to learn more about C-Vue, please visit our website at www.c-vuelc.com, or you can call me at 864-967-9525. Thank you for your attention.